All right, ladies and gentlemen, we're going to be talking about the square root function and how to graph it using transformations. So this is essentially the same thing we've been doing for the cubic function as far as transformational graphing is concerned. But the only difference now is, as you can see, we have a different shaped graph. So this is a square root graph, which means we have two different starting points. You notice these starting points should look very familiar to you, and I'm only asking you to memorize two of them. The domain and range are listed here. This domain and range is only for this parent graph, okay? The function looks like this. It's a square root function, and we're going to go ahead and start graphing this thing. So again, your reference points, think of these as your starting points. These are the things we're going to use, the points we're going to use to start our graph. So if I graph these things, they look like this. There is 0, 0, and 1, 1. It's going to be up to you to understand that since we have a square root function, that these 2 points, we don't connect them like a straight line. We connect them with this sideways parabola curve. All right, let's go ahead and start talking about how to graph these things. All right, so as you can see, the rules of transformational graphing all still remain the same. This did not change from the cubic function. For example, the A value still controls vertical stretch compression and reflection across the x-axis. It multiplies with your Y values. Your B value controls horizontal stretch or compression, reflection across the Y-axis, and it multiplies with your X values. H is a left to right shift, also called translation. This adds or subtracts to your X values. Remember, H, we got to switch the sign before we use it. And K translates up or down, or shifts up and down, and it adds or subtracts with the Y values. The transformational graph of a square root function can be seen here. You'll find the A on the outside of the square root. The B will be on the inside of the square root, as well as the H, and the K will be outside of the square root. I want you to think of the square root as parentheses, as you will see when we start graphing these things. Okay? But essentially the rules are exactly the same as we did before. So before we get into graphing, I want to talk about the domain and range of square root functions. So what I've done here, we have two functions. Here's the first one. I've graphed it for you. And here's the second one. I've graphed it for you. The only difference between these two functions is the A value. If you look, we have an A value of 4. This one has an A value of -4. So it causes a vertical flip or a reflection over the x-axis. Okay? I want to talk about the domain and range here. So if you look up top, I have some rules for domain and range. To find the domain, it's pretty simple. If you look at the graph, all we have to do is take the equation, so the stuff inside the radical, and we are going to equal it to 0 and solve. So let's try that. So we're going to take x plus 3, equal it to 0, and solve. If you subtract 3, you get x equals to -3. So how does that affect my domain? Well, if we did our domain for this guy, we would have this domain. So remember, domain is how far wide, or how wide is my graph. So how far to the left does my graph go? If you look, it only goes as far as -3. And you'll notice it's actually what we got when we did this little rule here. So my domain is actually -3, comma, and then how far to the right does it go? It goes into positive infinity. Okay? So I want you to notice is this guy matches what we got for x when we set the radicand equal to 0 and solved. And that's kind of what the rule is talking about up here. Okay? So how does that look when we have an a value that's negative or causes a flip? So we're going to set the radicand equal to 0 and show you what the domain looks like for this graph here. Okay? And as you might already know, when we set this equal to 0, we're going to get the same exact answer. X is going to equal to -3. So if I did the domain for this graph here, it would look something like this. So the domain would be, how far to the left do I go? If you notice, we go to -3. And how far to the right do I go? We go to positive infinity still. So, just like we talked about before, this guy will match this guy, which is the rule I'm talking about here. So we can actually find our domain by just solving for the stuff inside the parentheses by putting it equal to 0. Now, how does the k value come into play as far as the range is concerned? So the rule here for the range is we're going to use the k value to find the range. So let's go back to this guy. So for our range, our k value is this guy here, which is -5. When we write our range for my first graph, we're going to have this range. Remember, the range is how tall my graph is, starting from how low does my graph go to how high does my graph go. So the first number is how low does my graph go? It goes down to -5. So my range would be -5, comma, how tall is my graph or how high does it go? And it's going to go up to positive infinity. And what you should notice is -5 is actually your k value. Okay, how does it look like for our other graph when it's flipped upside down? So our range in this case, it's going to look slightly different. So our -5 is still our k value. So now when we do the range, we look, how far down does my graph go? Since we're going down and we have an arrow pointing down, that means my range is, in this case, is going to be -infinity. And then how far does my graph go up? It's going to go up to -5. So as you can notice, my k value is still part of my range. It's just now it's in a different spot because my graph has flipped. So I just want to point out these rules and be aware that we have to watch out when our a is negative. It can change your domain and range. Okay, so just be careful. But your domain and range will come from these numbers here. So essentially your h value and your k value will help you find your domain and range. Okay guys, let's get into the graphing and then we'll also state our domain and range. So just like before, what I like to do is label my A, B, H, and K. Okay, we should get pretty good at this. So step one is identify these things. My A value is the number outside multiplying with the radical. So my A value is 1/2, which means I'm going to have a vertical compression. Okay, so I am making my graph vertically shorter. My b value would be inside the radical. Multiplying with the x, it's actually going to be 1, which means nothing's happening with the b value. My h value is -3, but I got to switch it, so it's going to turn into +3. So we have a translation to the right. And my k value is -1. We do not switch that sign. That means we translate down. So how in the heck do I graph this thing? We have to remember our original points. So my original points are 0, 0, 1, 1, and now we do our math. So we have our b value here and our a value here, and they will multiply. So my b value is 1, my a value is 1/2, and we multiply accordingly. So this still is going to give me 0, 0, and this will turn into 1, 1/2. Now we go ahead and do my h and k and add and subtract those. So my h is 3, my k is -1, and we get our final point. So we're going to have 3, -1, and 4, -1/2, if you do the math correctly. So let's go ahead and plot those. So we have 3, -1, and we have 4, 1/2. Sorry, that's -3, 1. We want 3, -1, and then 4, -1/2, which would be right there. And again, we have to remember, what does our graph look like when it's square root? It looks like a sideways parabola, or half of a sideways parabola. And now we can state our domain and range. Remember, we can use the rule that we talked about in the previous slide, or we could just look at this and do our domain and range, okay? So my domain is going to be 3, positive infinity. So 3, positive infinity. Again, our 3 is essentially our h value. Okay? And our range will be -1, positive infinity. So -1, positive infinity. And again, our range we can get from our k value. All right, so essentially it's the same thing we've been doing. So it should not have that much difference here. Okay, so pause the video. I want you to try to do B on your own, and then I'm going to just work out B without an explanation. I'm just going to show you all the work here. All right. All right, so if you did this correctly, your graph should look something like this. Keeping in mind, the reason it's upside down is because I have an A that's a negative value, and we have a reflection across the x-axis, so it flips upside down. A common mistake, a lot of students will get these 2 points and not know how to connect them because they forget that we have a reflection. All right, here's your final points. Here's the A, B, H, and K work, and here's your domain and range. All right, have a good one.